Yes, good evening all. Good evening, Jyoti. Good evening, guys. So hope my voice is audible. Is it audible, guys? Can you confirm once by typing audible on chat box? Yes, thank you. Thank you for confirmation. So still we have 4 minutes of time. So please do inform to your friends, guys. So ask them to join immediately. So exactly at 5:50, I'm going to start the session. Clear? So how many of them started practicing your lab? So now labware is visible to everyone, right? Guys, go through the labware. So complete lab program we have put there. So you go one by one. Okay. So once you have completed, you have to mention completed. Okay, maybe yes, sir. This weekend you are going to get your assignment. And even we have to conduct quiz too also. So even I'm going to release quiz also, guys. Prior to that, I'm going to put announcement, no need to worry. Okay, I think we had problem with your batch formation. So now it is ready. You all confirm your batch once. You talk to your batchmates. So we have divided your assignment into two parts. So part A is given by me. So there you have to solve some problems by your own by taking some data set. That data set also I have mentioned in the assignment. And second part is left to you people. So since it is group project, you people have to discuss with each other. You take any one organizational problem and you take any tools you have learned in big data system and implement it. Clear? So you will be having 15 days of time. So you have to submit your assignments. So within 15 days. Is this clear? Is this clear to everyone? Yes. Okay, guys. So now it is a time to start your session. So let me share my PPT. Hope my slide is visible to everyone. Is it visible? Can I get the confirmation? Yes or no, guys? So once it is visible, please do type me in chat box. Visible. Vinit, is it visible? Okay. Okay, fine, guys. So let us start with today's session without wasting time. So good evening once again, my dear students. I'm very much thrilled to be back with all of you for our 11th session of the Big Data System. But still, I'm covering 9th session, also 10th session concept. Sorry for that, guys, because I'm teaching very depth concept for each and everyone. That's why it is consuming more time. So before we dive into today's exciting topics, so as usual, so let me start with a quick thought. So it was the great inventor Thomas Edison. So who said genius is 1% inspiration. So 99% perspirations. My dear friends, this course is about building system that handle massive complexity. Okay. And it requires consistent effort, or as Edison puts it, perspiration. So keep that in mind as we tackle some of the most intricate component of the Hadoop ecosystem and the vast world of NoSQL today. Okay. So I think you're all ready for today's session. So can I get quick confirmation on chat box? So once you people are ready for today's session, can you all type READY in chat box? Yes, at least one or two students READY in chat box. Yes. Okay, guys. Thank you all. So let's begin today's session. So as usual, guys, last class we have started with Scoop, and we have completed Flume concept also. So in today's session, we have left with two more tools. What we have left in the ninth session. So these are all two coordination and scheduling tools. Okay, so the very first one is Zookeeper. So we all know Zookeeper is a indispensable for any distributed system. Okay, it is providing a robust, centralized coordination service. So we'll explore how it acts as the glue for Hadoop components. And finally, we'll go with Oozie. So as we know, Oozie is our job scheduler, so which helps us to define and execute workflows. Workflows is nothing but what, guys? A sequence of Hadoop jobs automatically, correct? No? So which is essential for production environments. Okay. So after that, so we are going to start with NoSQL concept. Okay, guys, so let us start with the very first slide. So the very first slide is focusing on Zookeeper introduction. Guys, imagine, so trying to manage a team of 1,000 people without any clear organizational chart. So no single source of truth for who reports to whom or what the company configurations is. So it would be chaos, right? So in a distributed computing environment like Hadoop, so where you have hundreds of thousands of nodes, so you need a single reliable point for coordination. Okay. Excuse me, guys. Excuse me. That's exactly what Zookeeper is. Guys, Zookeeper is a generic coordination service for a distributed system. Okay, so make a note of this, guys. So mainly this Zookeeper is designed as a lightweight store for metadata. Okay, it is not a replacement for distributed database. Try to remember this. Okay, it is used for small critical pieces of information like configuration parameters, okay, status information, or service locations. So typically in the few kilobytes range. Okay, you would not store your customer data in Zookeeper. Okay, you store your cluster's vital signs there. That's it. Okay, so a crucial feature. So my dear friends, you try to remember this. So it is strict ordering guarantee called total ordering. So we are going to call it as total ordering. The meaning of this is data item updates seen across all clients. So even those connected to different Zookeeper nodes are always in the same order. Understanding my point, guys? So this guarantee is key to maintaining a consistency view of the cluster state. And it is coupled with this is sequential consistency. Okay, so which is ensuring a client sees its own updates in the order they were made. Okay, so furthermore, Zookeeper allows data updates can be notified to clients. So this mechanism is called as watches. Okay, this mechanism is called as watches. Okay, try to understand this. What is watches? Guys, watches is how services can react immediately to changes. So like what configuration updates are node failure. A classic use case is leader election, correct? No? So in cluster, see, this is the best example for this, guys. So in cluster, only one node can be the master at any time. So here, in this case, we are going to call it as H master. Okay, let me write it. Okay, here, you have H master here. So it is called as H master. Okay, so that is in case of what HBase, guys. So Zookeeper uses a unique node ID and algorithms. So what type of algorithm it is going to use here? Guys, ring-based leader election algorithm it is going to use. Understanding my point, guys? So why? See, to reliably what? Pick one master. And all other nodes know where to look. And let's take a what? HBase cluster as a what? Concrete example. See, here I'm taking example of HBase cluster. A client, see in this case, a client needs to look up the what? Current HMaster node. The HMaster's address is stored in a specific Zookeeper path. That is the very first point you have to remember. And the second point is Zookeeper is used to track failures in the cluster with heartbeat and pick a new HMaster. So if the current one goes down, then it is going to pick the new HMaster. So this is critical for high availability. Try to understand this. So this is critical for high availability. And it also maintains lightweight cluster configuration data for HBase. So this is for HBase. So hope everyone understood this. Guys, it is the brain's control center for the distributed system. Okay, so here, transition. See, transition. This concept of coordination is so fundamental. So that is drives Zookeeper's entire architecture. So which we will analyze in the next coming slide. Okay, so let us show you Zookeeper architecture now. So look at here, guys. So let's peek under the what hood at how Zookeeper achieves its robust coordination capabilities. First, it is built in memory and as a Java application. So in memory and a Java application. Try to understand this. Okay, running in memory gives it the what high performance needed for a coordination service. So as reads are lightning fast. Guys, the data is organized like a simplified in-memory file system with directories and files. So which are called as Z nodes. Okay, I'm writing here. So which are called as Z nodes. Clear? So we will see the structure of Z nodes shortly, guys. So no need to worry about that. So crucially, Zookeeper itself is clustered. Okay, that's why it is called as ensemble. So because of this reason, it is called as ensemble. It is not a single point of failure, guys. It is a set of servers working together to provide high performance, high fault tolerant, and strictly ordered access to the coordination data. Now, for a core concept, Zookeeper is a CP system as per the what? CAP theorem. So remember the CAP theorem. So we have discussed in the what? First 8 session, correct? No. What is CAP theorem? Consistency, availability, and partition tolerance. So here we are picking only 2. That is C for consistency and P for partition tolerance. So here the Zookeeper prioritizes consistency and partition tolerance. The meaning of this is the event of a network partition. So it will choose consistency and potentially sacrificing availability by not responding to clients if it cannot guarantee data is up to date. Guys, to ensure durability and avoid a split brain scenario where two nodes mistakenly believe they are the leader. So it uses majority quorum. Okay, it uses majority quorum scenario. Okay, majority quorum within that ensemble. Okay, the mean, see guys, you have to understand this. See, a write operation is only considered successful if the majority of the servers, okay, for example, 3 out of 5. Okay, 3 out of 5. See, servers, I'm taking 3 out of 5, acknowledge it. If a node is not a part of that majority quorum, the client connecting to it might get no response for a write until the quorum is established. Okay. The underlying protocol for achieving this strict consistency is called as ZAB. Z-A-B. What do you mean by ZAB, guys? So ZAB is nothing but Zookeeper Atomic Broadcast. Zookeeper Atomic Broadcast. Okay, so this protocol ensures that all state changes are reliably delivered and processed in a total order. And client connect to any server using TCP session here. Okay, so this session handles requests, responses, heartbeats, and event notification. That event notification is nothing but what, guys? So event notification is nothing but watches again. Okay, so if a connection dies, the client automatically attempts to connect to another node, or the server detects the client's failure via the missing heartbeats. Okay, so finally, all the client transactions are time-stamped and ordered. Understanding my point? It is time-stamped and also ordered. Since the Zookeeper's role is coordination metadata, so it is the typical mean for read-heavy workload. So often seeing a 10:1 ratio of reads to write. So hope this is crystal clear to everyone. So is this clear? So till here everything is clear? Yes or no? Shall I get quick confirmation on chat box? Now try to understand the mechanism of data persistence and synchronizations within the Zookeeper ensemble. So it is built on a replicated in-memory database. So shall we proceed, guys? Shall we proceed? Can anyone type on chat box proceed? Okay. Guys, look at here. So when a write operations comes in, Zookeeper has a very clear path. Okay, so I'm listing one by one, guys. So I'm starting with the very first point. Guys, look at here. This is very, very important. I want each and everyone to concentrate now. The messaging layer ensures all writes first go to the leader. Okay, look at here. So here we have mentioned leader, correct? No? So the messaging layer ensures all writes first go to the leader. Only the leader can propose and commit a state change. Understanding? And the second point is the leader coordinate with the followers using the ZAP protocol. So here we are going to use ZAP protocol. Okay, it is in capital letter. ZAP protocol. So the updates are then logged on the disk for recovery. So this is the what? Durability part, guys. So once the change is committed by the majority, the memory copy is updated. Okay, the memory copy is updated across all replicas. So if a leader fails during this process, guys, a new leader is assigned. And the ZAP protocol ensures the committed changes are still applied correctly. The key takeaway here is all local replicas are kept in synchronization. Okay, all local replicas are kept in synchronization. Now for read operations, guys, it is simpler and faster. Okay, so reads are serviced from the local copy of the in-memory database. So no matter which server the client connected to. So this is why so reads are so fast. However, guys, because of this local read, a client might get a what slightly stale view of the data if the write just happened on the leader, but has not propagated to the specific follower yet. So this is why Zookeeper provides strong but not instantaneous consistency. So it is still guaranteed to be up to date with the certain time bound. The meaning of this is timeless. So which we will discuss later. The timeless part we will discuss later. Guys, you think of it as a what? Newspaper. Okay. So what is newspaper? What and all we will be having in newspaper, guys? So in newspaper, we will be having editor. The first one we will be having editor. The editor is leader here. The editor is leader here. Okay. So what is the job of editor? The editor writes the final copy and sends it to all printers, right? Am I right or wrong, guys? So who are printers here? So printers are nothing but followers. So printers are nothing but followers. Correct? No? The editor writes the final copy and sends to all the printers. So write must go through the editor. But you people, so who is you here? So you is nothing but client here. But you can read your local copy of the newspaper. So where you are going to read, guys, you are going to read it in followers in memory. Followers in memory data you can read as a client here. So that you can do very fastly. That is immediately. So this is the best example to understand. So read or write operations. Okay, guys, to interact with Zookeeper, you need to understand the fundamental building block. So where this data is stored. So that is the what Zookeeper data model. So which we will discussing in the what next coming topic. See, look at it. So I'm showing you here data model concept. Guys, Zookeeper's data model is beautifully simple and easy to grasp. Okay, so look at here. Look at the diagram. So what it is showing? It is showing some hierarchy, right? So it is a hierarchical namespace. Okay, just like your file system. But the nodes are called as Z nodes here. Each and every nodes are called as Z nodes here. So that is holding some data here. Okay, guys. See here, I have told you, right? Each Z node can hold some data. And along with that, so it can have path. So what path, guys? Unique path it will be having. So a path like slash config slash database URL, or it can be having, suppose I'm taking HBase means, so it will be having slash HBase and master location. Okay, the data stored here is typically light, guys. Okay, the data can be what? It can be status, it can be configuration, it can be location, etc. Okay, but usually just a few kilobytes of data. So we are going to store inside this. That's all. Very simple. Okay, and every Z node is more than just a data container. It also contains stat structure. It also contains stat structure. Guys, this structure holds vital metadata. So what and all it will be including, guys? So it will be including version. It will be including version. Understanding? What do you mean by version? Version is the number update on every write operations to the Z node, right? So this is very much crucial for optimistic locking. Okay, so you can ensure you are only updating a Z node if its version is what you expect. So preventing what? Concurrent updates from overwriting each other. And along with that, we have ACL. ACL is nothing but access control list. Access control list. Guys, this control who can read and write to the Z node. And along with that, what do we have here? So we have timestamp. So the time when the Z node was created and last modified. Guys, now here's the very important concept. So what are the important concept? The Z node types. Guys, most Z nodes are persistent in nature. Okay, persistent. The meaning of this is they exist until explicitly deleted. So however, some can be what? Ephemeral. Okay, ephemeral Z nodes are tied to the client's session. So if the client session ends, see, for example, the client application crashes or loses its connection. That is the meaning of session ends. In that case, the ephemeral Z node is automatically deleted by the zookeeper. Okay, so make a note of this, guys. Ephemeral Z nodes are key for leader election and service discovery. Okay, so as a service registers itself with the ephemeral Z node, and if it fails, the Z node disappears and it is signaling its failure to others. So however, ephemeral Z nodes cannot have children. Okay, finally, guys, so clients can set up a watch or event for Z node changes. Okay, so if the Z node's data, children or state changes, so zookeeper sends a one-time notifications to the watching client. Okay, so this is the heart of coordination. So which is allowing services to react to changes instantly. Guys, this elegant data model, so backed by the Ensemble architecture. So which is allows zookeeper to offer a set of strong guarantees that make it a reliable coordination service. So let's explore those guarantees, guys. So here we have listed few guarantees. My dear friends, zookeeper values lies in the rock solid guarantees it provides for your distributed applications. Okay, so when you build a system on zookeeper, you can be sure of these properties. What are those properties? The very first property is given as sequential consistency. Guys, this is the strongest guarantee I can tell you, guys. So it ensures that updates from a single client are applied in the order they were sent. So furthermore, it provides total order across all operations. Okay, so think of it like the global leader. So where every single operation across all clients has a unique, universally agreed upon what sequence number. So this is what makes cluster state management reliable. Okay, then what is the second one? The second guarantee is atomicity. Okay, an update to what data items is always a complete success or a complete failure. Okay, so it either succeeds or fails. So with no partial results, guys. So this prevents your coordination data from being corrupted mid-update. Then what is the third guarantee here? Single system image. Guys, this is also called as session consistency. Let me write here. So this is also called as session consistency. Session consistency. Guys, a client connecting to the zookeeper service will see the same view of the service regardless of which server it connected to. So once a client sees an update, so it is guaranteed not to see an older version later on. So it is like all copies of a ledger look the same to your client. And next one is reliability. You all know about reliability. So this is what durability guarantee. So once an update has been successfully applied, so it will persist from that time forward until another client explicitly overrides. Guys, it survives server reboots and failures because so it's returned to the disk log. That disk log is called as commit log here. That is called as commit log. Okay, guys, the last guarantee here is timeless. Already I've told you about timeless, right? Guys, this is the promise that the client's view of the system is guaranteed to be up to date within a certain time bound. Okay, so while it is not instantaneous like a what synchronous operation, you know that your view will reflect the latest state within a short. Okay, it is predictable window. Guys, these 5 properties together are what Zookeeper the go-to choice for coordinations in the big data world. So this is a very important point for your understanding of distributed system fault tolerance. So to make this concept even more tangible, so let's look at massive real world use case. So how Zookeeper is implemented at Twitter. So before that, let me look at your chat box. So if you have any doubt, you ask me, otherwise I will move forward. So till here everything is clear. So shall I get a message CC and chat box once it is crystal clear? Thank you. Guys, here we have a case study. My dear students, so when we talk about big data, so we have to talk about companies like Twitter. Okay, now it is called as X, right? So now it is X. So this platform operates at an incredible scale, and Zookeeper is a foundational component of its infrastructure. Guys, Twitter uses Zookeeper to store critical metadata for various coordination services. What does that mean in practice? Guys, it is used for distributed locking. Okay, it is used for distributed locking. So can anyone tell what is distributed locking here? Can anyone tell, guys, what is distributed locking? So in Twitter. Yes, you all understood, right? Zookeeper concept. You just take a scenario to explain me, guys, not an issue. No idea? No idea? Okay, not an issue, guys. Let me proceed. Guys, imagine a scenario where a configuration file must be updated by only one service at a time to prevent corruption. Zookeeper provides distributed locking, acting as a central referee to ensure only one service holds the lock at any given moment. Okay, then what is the second one I have given here? Leader election. Already I've explained about leader election, right? Just like in HBase. So Twitter system use Zookeeper to reliably elect a leader for various services. So which is ensuring high availability and also fault tolerance. Okay, both guys. So high availability and also fault tolerance. Try to understand this. Okay, so next we have service registry. Look at here, I have mentioned service registry, or we can call it as service discovery. Guys, this is another major use case. So when a new microservice starts up, so it registers its IP address and port in Zookeeper. So both IP and port, it will store inside the Zookeeper. Other services looking to communicate with it query Zookeeper to find its current location. So this is a dynamic service discovery, guys.
So if the service dies, so it's what? Ephemeral Z node disappears and the registry is automatically updated here. And next we are going to use cluster topology. Next is cluster topology. Guys, Twitter's various databases like their key value stores, our image or video storage system. See, all these things are store their cluster topology informations in Zookeeper. Okay, this include which nodes are available, which ones holds which partitions of the data, so on and so forth. Okay, and the last one here, pub sub messaging. And also we have compute platform. Guys, their messaging and compute infrastructure heavily relies on Zookeeper for tasks like leader election and maintaining shared state. The key takeaway here is, my friends, Zookeeper is not processing the tweets themselves. So it is managing the underlying infrastructure, the traffic lights, blueprints, and organizational charts. So that allows the what? Massive distributed system to function reliably at web scale. So then, guys, we have successfully closed our discussions on Zookeeper, the coordinator. Now let's quickly revisit the agenda, guys. So then we will jump into Oozie, the scheduler. So which brings our Hadoop ecosystem tooling discussions to the close. Okay. So now I'm talking more about Oozie. So hope everyone understood this case study, right? Guys, this type of question you are going to get in the examinations. So you all seen, right, in my first two question paper. So usually I'm going to ask you question on case study based or scenario based. So there, so for that reason, I've taken this example. So hope Zookeeper is crystal clear to everyone. Yes or no, guys? Can I get quick confirmation on chat box? So once you people are saying yes, then I will move to the next one. Oozie. So as I told, Oozie is a scheduler. Okay. So we are focusing on Oozie next. Shall we? So this is the final piece of the Hadoop puzzle we need to cover before moving to NoSQL concept. So that is your Oozie. So after we get data into Hadoop using tools like Scoop, tools like Flume. So and we use services like Zookeeper to keep the cluster running. And we need a way to what? Orchestrate the actual processing jobs. That's where Oozie shines. Okay. So now look at here, guys. So look at the introduction part. My dear friends, you just imagine you have a complex data processing pipeline. Okay. So maybe you first run a Scoop job to ingest data. So let me take here. So you are taking Scoop to ingest data. And then you are going to use Hive, query to what? Clean it. And finally, you are going to use Pig script to what? Summarize it. So you cannot run these jobs manually one after the other every day. So what do you need here? So you need automation, correct? No, you need automation. So this is the problem solved by Oozie. So this is the problem solved by Oozie. Try to understand this. Guys, this Oozie is the scheduler for Hadoop jobs. Scheduler for Hadoop job. Okay. So its primary role is to sequence multiple jobs using a specification input. So which is a what? XML file. So this is a XML file. Okay. This allows you to define a logical flow for your data pipeline. The best part about Oozie is its broad support for the Hadoop ecosystem. So it can schedule and execute a task written on various technologies like Hive, Pig, Scoop, or even regular Java and also shell script. Okay, so Woozy is built in Java language. Okay, Woozy is built in Java language, guys. Here it is mentioned. Okay, it is built by using what, guys? Java language. Okay, and it is runs as a what? Web application. Okay, but here's the clever part. It does not execute the task itself. So instead, it uses the Hadoop execution engine. Okay, like it is going to use MapReduce. It is going to use Yarn for processing purpose. To actually what execute the task, it is going to use either MapReduce or it is going to use Yarn. So what this means is that Woozy gets to what piggyback on Hadoop's robustness. The underlying load balancing and failover for the computer task is handled automatically by the Hadoop framework. So what is that Hadoop framework? It is nothing but Yarn, right? That is nothing but Yarn. Okay, Woozy just focuses on the sequence and dependencies. That's all. So how does Woozy know when a task is done? This is a beautiful question, right? Guys, it uses one of two mechanisms. What are the two mechanisms it is going to use? The very first mechanism it is going to use callback URL. Guys, tasks have a callback URL. They used to tell Woozy when they are finished, whether successfully or with an error, both. And the second one is called as polling. Okay, second one is called as polling. So Woozy can also actively poll the task status on the Hadoop job tracker. Guys, what you are understanding here? So this capability to sequence a job is what defines Woozy's main job types. So let's look at the three categories of Woozy jobs next. See, look at here. We have taken three categories here. The very first one is workflow jobs. Second one is coordinator jobs. And also third one is bundle. Let us understand one by one with example. Okay, this is the most fundamental type, guys. The very first one, that is workflow jobs, right? So this is most fundamental type. A workflow job defines a sequence of actions. The individual task like Hive job, Pig job, etc. And in the form of what? Directed acyclic graph. In the form of DAG. Guys, a DAG is simply a sequence where tasks flow in one direction. That's why it is directed. Okay, and there is no loops. So that's why we have mentioned acyclic here. And also it is preventing infinite processing cycles. Okay, see, look at the image given here. This provided image shows a perfect example. So we have start node. This leads to the Hive job. Okay, which is then fork into two parallel paths. See, fork into two parallel paths. So one is shell job, another one is Pig job. So which then join back together here and leading to a decision node, and finally end. See, look at here. Both the side we have end here. Okay, this is how you model the dependencies in your data pipeline. Okay, and next one is what, guys? Next one is coordinator jobs. So workflow jobs are great for defining the logic of the pipeline. But how do you decide when to run it? Correct, no? That's the coordinator's job. Coordinator's jobs are responsible for triggering the workflow jobs based on time and data availability. Okay, so for example, so run this workflow at 1 a.m. Okay, run this workflow at 1 a.m. every day. Or you can run this workflow as soon as the input data file for today appears in HDFS. So they manage the recurring schedule. And what is the last one? Last type. The last type is called as bundle. Okay, guys, The bundle is simply a package of workflow and coordinator job. It is a package of workflow and coordinators job. So when you have a massive project with multiple related data pipeline, a bundle allows you to manage them as one unit. So it is the highest level of abstractions in Oozie. So helping you to control the entire application lifecycle. Okay, guys, the workflow job defined by DAG, that is the what core of Oozie. So now let us look at the XML specification. So which is how we actually define this workflow in a production environment. So we'll start with the simple examples on the next slide. So look at the example I have given here, guys. So I want each and everyone to concentrate here because this is very, very important for your examination. So I put 3 stars here. Guys, this slide shows the core of Oozie. The workflow definitions written in which language we have used here? So we have used HPDL, Hadoop Process Definition Language. I'm repeating, guys. This is used by HPDL, Hadoop Processing Definition Language. So which is one of the what XML standard. Okay, you all look at this structure, guys. Okay, it begins with workflow application. Look at here. It begins with workflow application and has name. The name I've taken here as simple workflow. Correct now? Every workflow must have a starting point defined by the start to. See, inside double quote I have mentioned fork node. So this is the tag we are going to use here. Here it immediately goes to fork name. So under fork name, what I have mentioned here, I have mentioned fork node. Guys, the fork element is how we achieve parallelism. So it splits the executions path into 2 concurrent paths. One starting with job 1, another one starting with job 2. So make a note of this, guys. Parallelism is key to minimize overall processing time in big data. Okay, so what is next, guys? Next, we define the individual task as action. Look at here, individual task as action. See, we have separate action for job 1, we have separate action for job 2. Okay, inside this, you can observe here, action name is equal to job 1. So you would specify the details for running the job. So we are passing its argument, settings, the executable path. Understanding my point, guys? The executable path. See, example, the path to your pig script or high query file you can mention here. Okay. So crucially, every action must define a path for success and failure. Okay. So, okay, see, look at here. OK2, I have mentioned OK2. So OK2 is equal to join node. Guys, if job 1 succeed, the control flow goes to join node. That is the meaning. And next one, what is the next line? Error to, correct? No, error to kill job. Guys, if job 1 fails, the workflow immediately jumps to the kill job node. So job 2 has a similar structure, guys. The same similar structure I have used for job 2 also. You can understand by yourself. So next to that, what do we have here? Since we forked, we must eventually join, right? See, that's why I have mentioned join name is equal to join node to job 3. Guys, this waits until all incoming paths, that is job 1 and job 2, are complete before proceeding to job 3. Guys, finally, we have written action for job 3. Okay, so job 3 runs. If successful, it reaches the end name. Okay, it reaches the end name. Okay, that's why end name is equal to end we have written here. So where we have written end name is equal to end, we have written here. So if any job fails, so then what we have to do, guys? We have to kill the job, right? So we have to kill the job. Understanding my point? So, and also it is printing an error message and stopping the workflow. Guys, below the what flow, you see an example of what an actual Hive action specifications look like. Defining job tracker, name node, script path, and any parameter. Okay, so that example covered sequential execution and parallel executions with fork join. But what if the next step depends on a condition? See, that is handled by decision node. Correct? Now that is handled by decision node. Okay, so which we will see in the next coming slide. So is this slide clear to everyone? Is this slide crystal clear to everyone? I have taken line by line and I have explained you each and everything. So Yuvraj, now it is clear. Now it is clear. I think you have asked one question. There is a typo in action name for job 2. Okay, that you can correct yourself, guys. So Yuvraj, do you have any doubt now? Now it is crystal clear, right? What about others? What about others? Yes, Yuvraj is good. Thank you, Yuvraj. What about others? Everyone are understanding? This workflow is very, very important for each and everyone, guys. Okay, next, moving forward, guys, moving forward. See, the production data pipeline is rarely a straight line. Okay, so it often involves conditional branching. Oozie uses the decision node for this purpose. Okay, so in this example, the workflow starts and immediately goes to the decision node. The decision node is named as what, guys? The decision node is named as decision 1. Guys, the decision node contains a switch block. Look at here. This node is containing a switch block. So which is similar to the programming languages switch statement, guys. It evaluates conditions and direct the flow to the specific path. So even we have mentioned case. The case element is the conditional path. See here, case element we have taken here. So this is the conditional path here. Understanding? So here it checks built-in Oozie expression language function. Okay, so look at here, dollar open flower bracket fs colon exist, and inside that I have mentioned path equal to false. Guys, this condition checks if the file or directory, what is the file or directory I mentioned here, /test/abc does not exist on HDFS. If this condition is true, okay, the condition does not exist, the flow goes to job 1. The flow goes to job 1. Correct? No? If condition is false, the meaning of this is the file does exist. The flow takes the default to job 2. Default to job 2 path. So this is a powerful feature, guys. You can decide whether to run a data injection job or a recovery job. Data injection job is nothing but what? Job 2. And recovery job is nothing but job 1 here. That is based on the presence of a data file. Guys, the subsequent action nodes. See, subsequent action nodes. So we have mentioned for job 1, job 2, and job 3. And the kill and end nodes functions exactly as they did in the previous slide. So defining the word successful and also error paths. So this decision making capability makes Oozie an incredibly flexible tool for automating complex operational logic in a big data system. Okay, so far we have defined the logic, that is nothing but a workflow, and now we need to tool to make this logic run on a recurring schedule. So that's the coordinator's job up next. So is this clear to everyone? So before that, let me look at your chat box. So till here, everything is clear. So now I'm moving forward and I'm explaining you the coordinator. Yes or no, guys, quickly. Yes or no? I'm not getting any responses quickly. Yes. Okay. Yes, guys, look at here. Now I'm moving forward and I'm talking about coordinators. Once again, guys, it is struck. Yes. Once again, guys, there is a problem. Okay. Yeah. So here I was talking about coordinator, right? Guys, a workflow defines what to do, and the coordinator defines when and how often to do it. Okay. The coordinator is also defined in XML. It wraps your workflow with the scheduling and also control parameters. Okay, let's break down the key element in the coordinator app tag. Okay, so you just look at here, guys. The very first thing I have mentioned name. Look at here. I have mentioned name here. Guys, the name is nothing but the name of the coordinator. Okay, and next we have frequency. So next we have frequency here. So frequency, this defines the recurrence pattern. So similar to Linux cron expression. And here frequency is equal to 5 star 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 star. Means it will run every 5 minutes. And next we have start and end. Okay, start and end, the date and time range for which the coordinator should be active. So this example shows it running for several years. Okay, and finally we have one more as time zone. So this specifies the time zone for the schedule. So here we set the time zone to India. Okay, and next to that, so what do we have here? The control block fine tunes the execution. So the very first line we have mentioned timeout. Okay, timeout if the job takes longer than the specified time. So we have mentioned 1 minute here. Okay, so it is considered a failure and killed. Okay, so next to that, what do we have? So next to that, we have concurrency. Okay, so how many actions? Concurrency is nothing but how many actions? So instances of underlying workflow. So that can run at the same time. So we are setting it to 1. So which is ensuring only one instance run at a time. And next to that, we have execution tag. So execution tag defines the order in which waiting jobs are run, such as whether we have to use FIFO. FIFO is nothing but what? First in, first out. And next to that, we have throttle. Okay, this limits the what? Maximum number of concurrent action that can be submitted to the workflow engine. Okay, and next to that, we have action, guys. Look at here. Next to that, we have action. So this action block links the coordinator to its base workflow. It uses app path. It uses app path to point the location of your workflow XML file. Okay, guys, the coordinator is what transform your one-time data processing script into a robust, automated, recurring production pipeline. So this is a very important concept for setting up any reliable big data jobs. Guys, theory is great, but practice is better. So let's look at a small exercise that ties together your knowledge of Pig and Oozie. Okay, this is the small exercise we have taken here. So better you all of them note down this. Create 2 pig jobs using geosales.csv data and run through Oozie. So try workflow and use coordinator to run the workflow periodically. Okay, so let's cement our understanding with the practical exercise, guys, that combines what you have learned about pig scripting with Oozie orchestration. I'm going to explain you the theoretical concept. You people have to try by yourself by using the available lab. Okay, so the very first thing what we have to do, see, the goal here is simple but multi-layer. So the very first thing what we have to do, guys, we have to create two pig jobs. Okay, we have to create two pig jobs. Correct, no? By using hypothetical geoscale CSV. Hypothetical geoscale CSV data file. So you could have one pig job that aggregates sales by country and another that finds the top selling product across all regions. So this is what you can do here. And the second one, what we have to do, guys, secondly, we have to define an Oozie workflow. Correct, no? So that runs these two pig jobs. So you could try two scenarios. What is the scenario one? Scenario one is run them sequentially. Okay, run them sequentially. Sequentially means what? First job one and then job two. Okay, this is one scenario. What is the second scenario? What is the second scenario? Scenario two is run them in parallel by using what? Run them in parallel by using fork and join. Use fork and join notes we just discussed. So this is the second step you have to follow. And what is the third step, guys? Use a coordinator to run the workflow periodically. Okay, use coordinator to run the work periodically. See, for example, set the coordinator run this workflow every hour. So simulating a what? Real-time sales reporting pipeline. Guys, this exercise forces you to consider all components. The data source, the processing script of your pig, the logic of the pipeline, that is nothing but workflow, and scheduler. So scheduler is nothing but a coordinator. So when you start implementing this, you will see the power of Oozie in making your job run reliably. So please attempt this exercise after this session, guys. So it will be what? Invaluable for your hands-on learning. So hope how many of them are going to do this. So after completing your job, you can post it on. Discussion forum. So can you please explain the differences between concurrency and throttle? Yes, one of my friend Yuvraj is asking the differences between concurrency and throttle. So can anyone explain? Can anyone explain this? What do you mean by concurrency? What we have to mention in concurrency according to my discussion? So we have to mention how many actions, right? The meaning of that is instances of the underlying workflow that can be what? Run at the same time. Okay, so we are setting up to what? One instance at a time. That's it. So we have mentioned one instance at a time. And throttle means it will limit the maximum number of concurrent actions that can be submitted the workflow engine. Okay, that is my explanation. So if anybody of you people have understood means you can take one example to explain on. Okay, yes, guys, what about that question I asked you people, right? So can you solve this problem after completion of this job? And can you submit it on discussion forum? Yes or no? So this is one homework question I'm giving to you all, guys. Okay, this is the homework question I'm giving to you all. I think Oozie and Zookeeper, everything installed on your system. Pig is also installed on your system. By using that environment, you can solve this problem. Clear? Okay, so shall we take 5 minutes break, guys? Shall we go for 5 minutes break? So before I'm going to start 10th session concept. So can we take 5 minutes break? Okay, now the time is 6:50. So 6:55, I'm going to start the session. Okay, guys. Yeah. So now it is exactly 6:55. Can we start the session? Yes, you all ready, guys? So I'm back to the session. Shall we start? Yes, nobody is talking. Okay, yes, I got one reply at least. Okay, guys, not an issue. Guys, this is the summary. So I don't want to go through the summary, guys. I'm jumping to the next slide. Yes, yeah. Uh, See, we transition to the second and perhaps most significant part of our sessions today, the word of databases that challenges the conventional wisdom of RDBMS. So get ready for an in-depth explorations of NoSQL databases. Okay. Yes, as usually, guys, welcome back, everyone. So this is the official start of 10th session. And also, we all know it is a crucial topic in our big data system course. So that is called as NoSQL. Okay, NoSQL databases. Yes, guys, I'm jumping directly into what? The very important topic. Yes. Yes, my dear students, so let's quickly review the structure of our NoSQL deep dive. So we'll start with the proper introduction to NoSQL. Then we will spend a significant amount of time on the classification of these databases. And finally, so we'll dive into practical examples and case studies. Okay, so mainly we are focusing on three tools here. The very first one, we are focusing on Cassandra. Second one is MongoDB. And the word of graph database with look at what Neo4j and Tinkerpop. Okay, so this structured approach will ensure you walk away with a clear understanding of when to choose which type of database for your big data application. Okay, so let's not waste any more time and get right into the why. Okay, so why did we need NoSQL in the first place? Yes, guys. So this is the core of the problem statement. Guys, we all know. So previously we have started using traditional RDBMS. That is nothing but your relational database management system. Okay, that were brilliantly designed for OLTP. Okay, the meaning of this is what, guys? Online transaction processing system. Okay, so they are the backbone of banking systems. So accounting software and any application where you need system of records. Guys, the RDBMS strength lies in its strict consistency and durability guarantees built on the ACID properties. Okay, so if you are transferring money from account A to account B, you must have ACID guarantees. So otherwise, your ledger is corrupted. Correct, no? However, friends, these strict guarantees come at a massive cost when you hit web scales. Okay, so the meaning of this is scale and cost issue you are going to face in RDBMS. Okay, the RDBMS struggles with very large volume of data. That is one reason, especially when you need distributed and geoscale applications and very high transaction volumes. Scaling an RDBMS often means expensive vertical scaling, so which is ultimately limited. Okay, and the second thing is consistency and consistency versus scale trade-off. See, the modern web, however, has a different set of needs. Typically, web scale systems do not need strict consistency and durability for every use cases. So think about these examples, guys. So here I've taken few examples. So social media networking, social networking. So if your follower count temporarily shows one less for a few seconds, does it matter? Not really, right? The application still works. And the second example, I've taken log analysis. So you need high speed writes for massive log data. So strict consistency on every single log entry is unnecessary. And browsing retail catalog and are reading review blocks. See, these are read heavy application where a few milliseconds of delay in consistency is fine, as long as the entire site is available and fast. So for these applications, the benefits of scale and availability far outweigh the need for instantaneous absolute consistency. Okay, so while a scale and consistency are one part of the problem, the structure of data itself is another major challenge that RDBMS could not solve. So let's look at the second reason for why NoSQL emerged. See here, the second major driver for NoSQL is the limitations of relational data modeling. Okay, relational data model itself. Guys, RDBMS ensures a uniform structure and models relationship between entities using predefined tables and also foreign keys. But a new class of emerging application has very different needs, specifically it involving granular and extreme connectivity information. They need to model data that is semi-structured and has complex relationship embedded within it. The key challenge here is that this kind of information needs to be queried at scale without large expensive join. Correct, no? Large expensive join. See here, clearly I mentioned each and every points. So they see joins are the bottleneck in RDBMS at scale. So let's look at the example where modeling relationship is crucial. The very first example I've taken here, connectivity between users in a social media application. Guys, you don't just want a list of friends. You want to answer questions like, how many friends do you have between two hops? Correct, no? So an RDBMS would require multiple complex self-joins to answer this question. So which is computationally prohibitive at Facebook scale. Try to imagine, guys. And the second question is connectivity between companies. Connectivity between companies. Guys, analyzing relationship in terms of domain, technology stacks, or people skills is crucial for skill acquisitions or mergers and acquisition. Correct, no? That is M&A. And the last one is connectivity between IT network devices. Guys, understanding how devices are interconnected is a vital for troubleshooting incidents. Okay, problem is one router affect devices connected downstream. So this is a graph problem, guys. So when the relationships are more important than the data itself, and querying those relationships needs to be fast, the relational model is insufficient. So this is the birthplace of graph databases. Okay, a key NoSQL family we will discuss later. Guys, here what I would like to say here is NoSQL is the collective term for a group of databases that solved these twin problems of scale or consistency and relationship modeling. So let's formally define what NoSQL is. Okay, so what is NoSQL? I think everyone know this, right? My dear friends, let's nail down the definition of NoSQL. So interestingly, the term was first coined way back in 1998. By what? By Carlo Strozzi for a lightweight open source database that did not use the standard SQL interface. So it was a niche idea back then. But the term was reintroduced in 2009 by Johan Oscarson and took on a what new meaning as the internet giants force their scaling challenges. Today, NoSQL simply refers to non-relational databases. Okay, the name NoSQL is often considered a misnomer. Okay, it does not mean NoSQL at all. So instead, we prefer to think of it as a not only SQL. It is about having options beyond the relational model. The core essence of NoSQL databases, including these characteristics, guys. The very first characteristic is non-relational. Okay, so they are typically schemaless. So this is a massive break from RDBMS. So allowing for what? Flexible data injection without a rigid predefined schema. And they are loosen consistency. Okay, the C in ACID. The C in ACID to achieve high scalability and also availability, right? So this is where the CAP theorem comes into play. So favoring availability, partition tolerance, availability and partition tolerance. The entire movement was born out of open source community. Understanding, guys? So to address the what needs of web scale application, and they are fundamentally distributed for scale and designed to be cluster friendly. Guys, the defining characteristics of NoSQL, the non-relational part means a complexity different way of modeling data. So let's explore NoSQL data model next. Look at here, everyone. Okay, let's delve deeper into the fundamental. See, characteristics already you all understood, right? So now I'm jumping directly into the concept of data model. So all of them, look at here, guys. See, what is the very first point that I mentioned here? The data model is where NoSQL truly differentiates itself from the RDBMS. Okay, very first point that I mentioned, supports rich variety of data. See, it is mentioned NoSQL databases are versatile in nature. So they can handle traditional structured data, okay, but also semi-structured data like your JSON, XML. Even along with that, it can handle unstructured data like your videos or images, sometimes stored in a chunks. And there is no fixed schema. Understanding my point, guys? No fixed schema. Again, the flexibility is key here. So each record, each document, or each row could have different attributes. So this is perfect for applications where the data format evolves quickly or where different business units collect different kinds of information. And next one is non-relational. No join operations are typically supported. So this is an absolute key design principle. By eliminating the need for complex, resource-intensive join operations, NoSQL databases can achieve much higher performance and scalability. Okay, you generally denormalize your data, meaning you embed related informations within a single record to avoid join. And what is the next one? Transaction semantics for multiple data items are typically not supported. So unlike RDBMS, where a single transactions can update multiple tables. Okay, NoSQL usually only guarantees transactional integrity at the single document or single row level. So multi-item transactions are complex and often avoided to preserve speed and scale. And what is the next characteristics? So relaxed consistency semantics. So no support for ACID as in RDBMS. The trade-off is clear here. So sacrificing strict ACID for scale. So instead, NoSQL databases often rely on base properties. That I will explain you later. So means relies on what? Base properties. So basically available, soft state, and last one is eventually consistent. So this is basically available, soft state, and eventually consistent. So what is the last point, guys? Last point, in some cases can model data as a graphs and queries as graph traversals. So as we mentioned, for highly interconnected data, a subset of NoSQL, the graph databases provides an entirely different powerful data model. Guys, now that we understood the philosophy, so let's explore the four major categories of NoSQL, because choosing the right one is the first step in designing your big data system. So now look at here, guys. What is the very first one? So when someone say NoSQL, you should immediately ask, sir, which kind? Because there are four major distinct families. What is the first one, guys? The very first one is key value stores. Guys, let me explain you the concept first, and then I'm going to explain you the strength. Guys, let me talk concept here. So this is the simplest model. So essentially a big hash table of keys and values. The key is unique here and the value can be anything. Okay, so anything means you can take a string, JSON object, or a complex binary structure. Then what is the strength of this, guys? Strength is extremely fast lookups. So it is ideal caching or storing user sessions. So example for this is Dynamo, Redis, and React, so on and so forth. So this is the very first classification. Then what is the second classification? The second classification is document database. Then what is the concept behind this, guys? Guys, data is maintained in collections of documents. The document is typically a semi-structured format like JSON, or we can take BSIL. Okay, so documents can contain nested structures. You can consider arrays, objects, so on and so forth. The strength of this document is, so it is great for handling complex hierarchical data with flexible schemas. The best example for this is MongoDB and also CouchDB. So MongoDB we will discuss later. Okay. And what is the next one? The next one is column family database. What is the concept behind this, guys? See, data is stored not by row, but by column family or column. That we have discussed already, right? So each storage block has data from only one column. So this is extremely efficient for analytical queries that only read a small subset of columns. And the strength of this is, see, massive horizontal scalability and high write throughputs. Example for this is Cassandra and also HBase. HBase already have discussed. So I think you people are already familiar with column family concept. And what is the last one? The last one is graph databases. Guys, this also known as network databases. They store data in nodes. Okay, each nodes are called as entities here. So each nodes are called as entities here. And so we are going to use edges. Okay, so edges are nothing but relationships. And entities are nothing but nodes here. And the strength of this graph databases are unmatched performance for querying complex multi-hop relationships. So example for this is Neo4j, HyperGraphDB, and Apache Tinkerpop. Guys, this diversity is a massive advantage, guys. So let's look at the incredible scale that these architectures can achieve. So which is their defining features. Okay, so let me check once whether anybody has asked any question. Till now, everything is clear. No question till now, guys. No questions means I will move forward. Do you have any questions? No, right? Shall I get quick confirmation and chat box? Thank you. Okay, yes, guys. So scale is the reason for NoSQL existence. Correct, no? They use scale out architecture. So instead of what? Traditional, expensive, monolithic architecture of relational databases. Guys, so scaling out means what? Scaling out means adding more commodity servers to your cluster. Okay, not upgrading a single bigger machine. So this design allows for 3 incredible levels of scale. What is the first one? The very first one is cluster scale. So these systems can be distributed across 100 plus nodes across multiple data centers. So this geographic distribution is vital for global applications and disaster recovery. Okay, then what is the second one? The second one is performance scale. The second one is performance scale. Guys, they can handle incredible workload. So after achieving 100K plus DB database reads and writes per second. So this high throughput is a direct result of horizontal scaling and relaxed consistency. And finally, what do we have here? So we have data scale. Guys, NoSQL databases are designed to house massive amounts of data. So it is supporting over 1 billion documents or 1 billion records. Is it not interesting, guys? So beyond raw capacity, so these databases have built-in features to manage this scale. What are the built-in features? The very first built-in feature is dynamic schema. So we mentioned this, right? So it allows insertions of data without a predefined schema. So this flexibility accelerates application developments. Okay. And the second one is auto sharding. Okay. This is very crucial point you have to understand, guys. Okay. So sharding is the process of partitioning data across multiple machines. Sharding is nothing but partitions. So auto sharding automatically spreads data across the number of servers in the cluster. Okay. So the application is then not aware about it, not aware of what the data lies. So this helps in data balancing and failure recovery. Okay. So as if one server fails, the data is still available on others. The system can redistribute the load. And the last point is replication. Guys, they have excellent configurable support for replications of data. So which directly offers high availability and fault tolerance. So with all these advantages, so there must be what? Some trade-offs. So let's weigh the pros and cons of moving to NoSQL model. So here we have mentioned pros and cons. My dear friends, there is no silver bullet in technology. Correct? No? I think everyone will agree with my point. And NoSQL is no exception. So let's look at the what trade-offs involved. The biggest sacrifices are the strength of RDBMS. No ACID property for transactions. See, for mission critical multi-item transaction, you lose the automatic ironclad guarantees of ACID and loss of complex operations. Correct? No? See, you lose the what ability to easily perform complex join between data sets or table and sophisticated group by operations and lack of standardization. What do you mean by that, guys? So there is no single SQL interface. Every NoSQL databases has its own query language. So we have to use MongoDB query language. We have to use Cassandra query language, Neo4j Cypher. Understanding my point, guys? There is a what? Lack of standardization. Okay, so this lack of standardizations makes it difficult to switch between different NoSQL stores or port from SQL. And next one is what? Skill and tooling. Guys, the community is growing, but there are less mature BI tools and comparatively less available skilled talents than the decades old RDBMS space. Understanding my point, guys? And what are the pros, guys? The pros means the gains are all about speed, scale, and flexibility. Okay, the very first point what I would like to mention here is scale and cost. Guys, they are cost effective for large data sets, are easy to what distribute. So especially across any of the what data center. Okay, any of the data center. Okay, and easier to what scale up and down. And what is the second one? The second one is flexibility. So they allow for no predefined schema and make it easier to what model semi-structured data or connectivity data. And third one is performance. They relax data consistency when required to prioritize performance and speed. And fourth one is availability. Okay, they easily support data replications for high availability. Guys, this comparison should make the choice clearer. So let's formalize this differences between the two words in a side-by-side comparison. So NoSQL versus SQL. Guys, this table summarizes the war between the old guard and the new guard. Okay, so where I've taken, the very first one I've taken SQL and second one I've taken as NoSQL. And type also I'm mentioning here. So what type I have taken here? Based on this type, I'm taking the what similarity or whatever you want. The very first one is schema. The very first feature I've taken here is schema. We all know, right? So here I'll be having predefined schema. Okay, that is little bit rigid. And here it is schemaless. So that is flexible in nature. And next I'm taking structure. So what type of structure I'm using here? I'm using table-based databases. So with respect to SQL. But in case of this NoSQL, multiple options. I can go with the key value, document-based, column-based, or graph. Okay. And next I'm talking about scalability. So here this is vertical scalable and here it is horizontal scalable. Okay, horizontal scalable means what, guys? Horizontal scalable means more machines. So here vertical scaling means, so we are going to increase the capacity of the single system. The meaning of this is bigger machines we are going to use here. And what is the next one? Guarantees. Already I've explained you about guarantees. So this supports ACID properties, but NoSQL supports CAP theorem. So it is prioritizing AP or CP. And querying. So once I'm talking about querying, so it supports complex querying. And also it is supporting for what? Join. But here, relatively simple query. So and also without joining, we can perform any of the query here. And what is the last one? Support we have taken. So excellent support from vendors. So we have Oracle here. We have Microsoft to support in what SQL. But in case of this, so it is relies heavily on community support. Okay, so these are the similarities I've given, guys. So make a note of this table. Okay, so it is the most succinct way to summarize the core architectural differences. So SQL is about integrity first, scale second. NoSQL is about scale first and integrity second actually. Okay, so there is no better option. There is only the right tool for the job. You use SQL for your banking ledger. Okay, suppose you are using systems of records. You use SQL. NoSQL for your user session cache or social network graph. Suppose system of engagement you have missed, then go with NoSQL. Guys, the NoSQL movement has been driven by the world's largest companies. Okay, so let's look at some of the what major players and vendors in this space. So here I mentioned clearly. Look at here, guys, vendors. I'm showing you some vendors here. My dear students, the NoSQL landscape is incredibly vibrant and is being shaped by the biggest names in tech. The vendors fall into a few key groups. Okay, so what are the few key groups? The internet giants. Okay, so these companies created the databases to solve their own internal scaling problems and later open source them and release them as cloud services. What are those, guys? The very first one is Amazon. Okay, so Amazon created what? Amazon is created. Amazon is created DynamoDB. So this DynamoDB uses either key value or document databases. And what is next one, guys? The next one is Facebook. So Facebook created Cassandra. So Cassandra is purely column family. Okay. And third one, Google, the concept of big table. So big table again comes under column family databases, and along with that, Spanner. So this is heavily influenced the entire movement. Understanding my point, guys? So these are all the what? The internet giants. And the second point I'm taking here is the open source community are specialist vendors. Guys, these are the dedicated companies or projects that pioneered specific data models. What are those? The very first one is MongoDB. Okay, so MongoDB, the leader in the documented database space. And next we have Apache HBase. So already I've explained you about Apache HBase. And also one more is Cassandra. So these two are leaders in what, guys? Leaders in column family space. And next we have Redis. Okay, the most popular in-memory key value store. And we have Neo4j. Okay, so Neo4j, it is the what? Leading native graph databases. And third point, what I'm taking here is the traditional players. Guys, even the old RDBMS giants are getting into the game, like your Oracle. Okay, so Oracle with the what own NoSQL databases offering. What this shows, guys, is that NoSQL is no longer a niche technology. Okay, it is mainstream with a powerful backing from both the open source community and major corporations. Okay, so we are going to spend the next few slides reviewing the what 4 classifications in more detail before we dive into the specific examples of Cassandra and also MongoDB. Okay, so look at here, guys. Okay, this is we are discussing on document-based databases, and we are discussing on key value stores, column-based databases, graph databases, so on and so forth. Okay, yes. Yes, so what is the first one, guys? The very first one we are talking about document-based databases with MongoDB concept. Okay, so being the what most famous example I'm taking here. Store data in the form of documents. Okay. Guys, what you have to understand here, the very first point what you have to understand here is document format. Okay, so these documents use well-known human readable machine parsable format like JSON. So what is JSON, guys? JSON is nothing but what? JavaScript open notation. Correct, no? Guys, MongoDB uses binary JSON. That's why it is called as BSON. Okay, so let me write here. So it is called as BSON. Okay, so which is a what binary representation of your JSON actually. So this is offering faster sync. This is the first thing you have to understand, guys. And the second thing, what you have to understand, organization. Okay, so documents are grouped into collections here. So documents are grouped into collections. So which is similar to a table in an RDBMS, but with no fixed schema. This is the second thing you have to understand, organization. And third thing you have to understand, access. Third thing you have to understand, access. Guys, documents are primarily accessible via their unique ID. But they can also be what accessed through other fields by setting up an index. Okay, you just look at the example, guys, then you will understand. Guys, here I have taken the example of book document. Okay, it is a single self-contained record. Okay, it can contain nested fields, list, and different data types. Correct, no? So if I add new book and decide to include language field, but I don't add it to this book, the database does not care. That's the power of schemaless nature. Understanding my point? That is the power of schemaless, guys. And document DBs are excellent for. Document DBs are excellent for what, guys? These are all excellent for DMS, content management system. Okay, a blog post or a product catalog entry is a what perfect document. And this is excellent for e-commerce. It is excellent for e-commerce, storing customer cards, storing customer orders and product details. So then we can use it. That means, guys, see, look at here. This images shows how you can model relationship by using one document's ID as a reference in another. See here, we are using ID. By using this ID, so we have used this as a what reference in the next two documents. Correct, no? So similar to, it is very much similar to what, guys? It is very much similar to foreign key concept. But the data is still stored as a what separate document. Okay, guys, let's move to the what simplest and fastest of all NoSQL types. So which is primarily used as a high-speed cache layer. What is that, guys? That is called as key value store. That is called as key value store. It is very easy to understand, guys. You have to concentrate here, guys. That's it. My dear students, the key value store is the absolute simplest data model in the NoSQL world. It is the simplest model, guys. Okay, so that's why I have used the very first point is simple data model. So it is based on the fastest possible access method. So looking up a key to retrieve the entire value associated with it. Okay, so this is no complex query, no indexing on the value, just a lightning fast lookup by the key. That's it. And it also containing underlying structure. Guys, it literally maintains a big hash table of keys and values. Okay, and next I'm talking about the values. Guys, while the model is simple, the value itself can be very complex. Okay, so it can be simple string, it can be structured record, it can be full document. Okay, or even a complex data structures like you can take list, set. So as it common in what Redis. Okay, so look at the example provided here. So look at the example provided here. A student roll number is the key. Okay, student roll number is the key here. So I've taken 2014 HW 1122 20. And their entire record is value here. See, Santosh, Sharma, Pilani. Okay, guys, key value stores are primarily used for caching. Okay, this is primarily used for caching. Guys, storing web pages or database query results that are frequently accessed, right? So that's why. So we are use it for what? Caching. And second one, we are using it for session management. See, for example, storing user session data for web application. See, example, shopping cart contents. So there, what is important, guys? Session management is very, very important, right? And the third one is leaderboards or counters. See, for high speed read or write access to a simple data, then when a leader records or counters. Guys, from the simple key value, so let's move to the model designed for massive analytical speed at petabyte scale. Okay, petabyte scale means what we have to use, guys? We have to use column-based database, correct? No. So I'm talking about column-based database next. So which is mainly used in Cassandra and also which is mainly used in HBase. Okay. So see, column-based or column family databases are a fascinating vertical partitions of the traditional data model. And this is what makes them incredibly performant at scale. The very first point I would like to discuss here is partition by column. Guys, instead of storing all data for a row contiguously on disk, the column-based model partitions a table by column into column families. Okay. And the second point I'm considering here is storage. A part of vertical partitioning. So each column family is stored in its own files. So most critically, each storage block has data from only one column. Understanding? You just imagine, guys, a table with 100 columns. Okay, to explain this, so I'm taking one example. A table with 100 columns. In an RDBMS, even if your query only needs 2 columns, the system often has to read the what? Entire row, right? All 100 columns it has to read from the disk. Am I right or wrong, guys? In a column-based database, if you only need those 2 columns, the system only has to read the files corresponding to those 2 columns. So dramatically reducing input output and increasing query speed. Okay, so this makes them perfect for analytical workload. See, in OLAP, so where queries often involves aggregates on a few columns across many rows. So in that situation, we are going to use this. And what is the third point? So they also allow for versioning of data values. So you can store multiple versions of a single sales value. So which is useful for audit trials or time series analysis. And examples like, see, and one more very, very important thing is examples like your Cassandra, HBase use this model. Cassandra uses flexible column family structure. HBase is strongly influenced by what? Google Big Table Paper. Okay, so it is offering high speed reads and writes at a colossal scale actually. Okay, so finally, guys, let's explore the last and most structurally what different classification. So that is called as graph databases. So which are vital for modeling intricate relationship in big data world. So what are those, guys? That is graph based. Okay, so all of them, look at here. Okay, graph databases sometimes called as what we are going to call it as, guys. We are going to call it as network databases. That already I've told you. So this is already also called as what? Network databases. So these are built from the ground up towards all the relationship problem. Okay, then look at here. The very first point I'm discussing here is data representation. It is very easy to understand, guys. Data is represented as a graph here. Okay, so which is consisting of nodes. See, for example, entities like person, movie, everything is called as nodes here. And we are going to use edges. So edges are nothing but what, guys? Relationship between the nodes. So like acted in, okay, friends with, so on and so forth. Both nodes and edges can have properties. What properties it will be having? So it will be having the properties of key value pairs associated with each other. Okay, that is the very first point you have to understand. And second point is querying. Okay, second point what you have to understand here is querying. The magic happens in the queries. Guys, related nodes can be found by traversing the edges using a path expression. So this traversal is a native operations. So meaning it is extremely fast regardless of how large the graph is. This is why a query like find friends of friends is nearly instantaneous in a graph database, while it would crush an RDBMS. And third one, what we are going to take here is, so third one we are going to take query languages. So they use a specialized graph query languages such as, okay, Gremlin and Cypher. So we explore these two later, guys. So here you can see the image. This image shows a perfect graph. So what it is containing? It is containing three nodes, right? So one is Alice, and second one is Bob, and third one is, what is the name of third one? Chess. Okay, and directed edges are showing the relationship and also properties. Okay, guys, what you have to understand here is, so these graph databases are indispensable for what, guys? Social networks. Okay, so friend suggestions, influence analysis. So that is comes in social networks. And second one is recommendation engines. So based on connections between users and product, you can recommend the engines. Okay, and fraud detection. Suppose you are identifying complex hidden rings of fraudulent accounts, then you can use this. Guys, we have now covered all four classifications. So before we dive into Cassandra and MongoDB, so let's take a final look at our roadmap. Okay. So this is the roadmap for what? The next coming topics. Guys, just a quick check on our trajectory. So we have covered the what and why of NoSQL. So along with that, a fundamental four classification is done. The final and most substantial part of our session now is to get practical. So we are going to dedicate a significant time to looking at the leading examples in the document, column, and graph. Okay, so we are discussing Cassandra, so which is column family, MongoDB, so which is document family, and Neo4j and Tinkerpop. So these are graph databases. Guys, this detailed look at their architecture, consistency model, and query patterns will provide the necessary knowledge to use them in your own big data project. Okay, so now let's start with the Cassandra concept. So the highly scalable and highly available column family store, that is Cassandra. Yes, guys, let us start with the theory. So meet Cassandra, a database born at Facebook and heavily influenced by two seminal paper. So Amazon Dynamo, one is Amazon Dynamo, that is key value database, and one more is Google Bigtable, which is column family. So this combinations makes it powerful house. Okay, so CAP theorem design. See, look at here. We have mentioned CAP theory design here. So Cassandra explicitly an AP design in the CAP context. So what it is prioritizing? It is prioritizing two things, availability and also partition tolerance over strict immediate consistency. Okay, so this makes it ideal for high performance, high availability applications that can sacrifice consistency. Okay, so the next topic I'm taking here is architecture. So it is built for peer-to-peer systematic, means what, symmetric nodes architecture. Guys, unlike MongoDB, So which has a what? Primary, secondary setup. Every Cassandra node is a peer. So there is no single leader, that is single point of failure. So this peer-to-peer nature is the secret to its massive scale and fault tolerance. And what is next? So next I'm considering data model. Okay, so it is the what? Column oriented database. So following the what? Column family model we discussed earlier. Okay, the structure is defined as, the structure is mainly defined as key space. Okay, let me write here. That is not mentioned. Yeah, it is mentioned here. Key space is nothing but what, guys? So key space is nothing but database. Okay. See, look at here. I have mentioned the very first one is column family. So column family, CF, we can call, we can write it in short form, CF. So this is like a what? Table within the key space. Correct now? Inside database, we have a what? Table. That is called as column family. And what about attributes? Or we can call it as columns, right? So these are the actual fields within the column family. So with their specified data types. And make a note of this structure, make a note of this architecture. So the AP design and peer-to-peer structure are the defining features of Cassandra. Make a note of this. Guys, the AP design of Cassandra requires a unique approach to managing data persistence. Now we are looking at read or write path. Look at here, guys, read or write path. And my dear students, the way Cassandra handles data persistence is highly optimized for fast, reliable writes. Okay, the very first point I'm discussing on writes only. Writes. The very first point what I'm showing you here, I'm showing you commit log. So when a write comes in, so it's first returned to a what? Commit log sequentially on the disk of the node that received the request. Once this write is logged, the operation is immediately deemed successfully from the perspective of durability. Okay, this is an append only sequential write, so which is extremely fast, guys. And next one, I'm talking about mem table. Okay, so simultaneously, the data is indexed and put into the in-memory mem table. And next to that, what do we have here? So we have SS table. When a mem table is full, so it is flushed to the disk file called SS table. SS table is nothing but what? Sorted string table. Sorted string table. Okay, and next one is immutable, immutability. The SS table is immutable and append only. Okay, the meaning of this is updates don't change the SS table. They create a new entry in the new SS table. Okay, so this design is what makes Cassandra's write performance so stellar. And what is the next one? Next one, I'm talking about distribution. Guys, partition and replications happens automatically here across the what peer nodes in the cluster. So this is about reads, writes, guys. So next we are talking about reads. Guys, in reads, the very first point what I've taken any node. A client can connect to any node to read the data. And second thing is consistency level. Guys, this is where Cassandra flexibility shines. Okay, the consistency level decides when a read is returned. So the client specifies how many replicas must contain the same copy before the read is considered successfully. Understanding my point? And next one, read repair. So if a client asks for a what consistency level that a node cannot immediately meet, Cassandra can trigger a read repair. Okay, this uses gossip protocol, a communication mechanism between nodes, to update the inconsistent replica in the background as the client issues the read. Guys, That consistency level is most critical concept in Cassandra. So let's dedicate the next to 2 slides to understand its consistency semantics fully. Okay. So I will take extra 10 minutes time, guys. So I will finish this and then I'm going to close the session. Okay. Still we have more topic to discuss. Otherwise, we can stop here only, guys. So consistency semantics we can discuss in the next coming class. Okay, so how many slides I have completed? Only 36 slides. So I have left with 30 more slides. 30 more slides and 30. Next class, I will be having 60. Okay, then yes, guys, that's all for today's session. So since we have lots and lot of theoretical concept, it will bore you. So I don't want to continue. So is it okay for you all, guys? So as usual, I have to take one extra class to complete the 11th session concept. So let me finish 10th session concept first, and then I can jump to 11th session concept. Okay, that's all for today's session, guys. If you have any questions on today's session, you can ask me. So how about today's session? Is it interesting? NoSQL concept. Is it interesting, guys? I'm not getting any responses. Lot of tools, yes. So that's why big data tools is nothing but. So we are going to discuss lots and lot of tools. So decision is left to you people, guys. Which tool you want, that is left to you people. So that's why this time we have introduced situated learning assignments. Okay, situated assignments we have created this time. Situated learning is nothing but what, guys? You have to take the problem from your company, your organization, and then use any of the big data tools to solve that. So for that, I'm going to give you 10 marks in the exam, 10 marks in your assignments, guys. So we have divided your assignment into 2 parts. So one is, see, I'm going to give you the problem. So there compulsorily you have to use Hadoop, MapReduce, HBase, Hive, and Pig. So 5 tools compulsory you have to use. So for that, I'm going to give you queries and also problem statement I'm going to give you. So you people have to solve all the problems by using the tools. Okay. And also, guys, you have to compulsorily submit your snapshots and you have to utilize your lab. See, whatever the lab we are providing from the bits, that lab only you people have to utilize. You're not supposed to solve your problem on your own system. So for that, I'm not going to award any marks in the assignment. You have to solve the problem in your assigned lab only. That is the first thing. And second thing is situated learning. In situated learning, you take your company problem. See, suppose you have a group of 4 men. So any one problem, you can stick on to any one's organization's problem. And you people have to solve that problem by using minimum 2 tools we have discussed in the big data system. So this is what we have introduced this time as an assignment. So let me check how many of them are going to send back a very good assignments. Okay. So based on that, I'm going to decide your outcomes. So is this clear to everyone? So if you have any questions on assignments, you can ask me. So hope I've done with my session today. Any question on assignments, guys? So we have Niklesh, Meghna, Yuvraj. Sir, what is the start and end date for assignments? Actually, it is mentioned in your calendar. So we have to start from November 1st. But before that, I'm going to release, guys. Okay, we have to conduct one more quiz, right? So maybe, yes, this Thursday, I'm going to release quiz. Still next time, next week, you have 25th, right? So maybe, yes, 25th to 1st. So I'm going to release the assignment. So why you are asking this question? Kukunur, why are you asking this question? So this week I plan to release the quiz, and next week I plan to release your assignment. So just last week I finalized your groups. Okay, so many of them were in what? 5 people in a group, right? So we have done so many manual work to remove students from the 5. So better planning other assignments are there. Yeah, okay, Niklesh. Yeah. So this week I'm going to release quiz, and next week I'm going to release assignment. Is it okay, Niklesh? So I'm going to give you sufficient time, guys. 15 days of time you are going to get. Actually, in handout, we have mentioned only 10 days, but we are going to give you 15 days of time. So I want outcome, guys. So I have to see you people have solved the problem correctly or not. So please, once again, could you tell about mark split up among the 2 parts in assignment? Guys, Meghna, part A, it is a guided project. So we are going to give you, see, you people have to take some synthetic data type, or I have mentioned, so where you are going to get the data set, and then you have to use compulsorily HBase, Hadoop, and Hive, Pig, and one more tool to solve that problem. That is your part A. So part A carries 10 marks, and the second part is what? Situated learning. So situated learning carries 10 marks. So situated learning means you have to take your own problem, so from your organization, and then you have to what? Come out with solutions by using any of the big data tools. Is this clear, Meghna? Part A carries 10 marks, part B carries 10 marks. So suppose in your group you have 4 people from different organizations, means you take anybody's problem, guys. So it is not mandatory you have to take 4 different problem statements. You take in your group, you choose any one problem from that particular organization and solve that problem. And clearly I have mentioned, see, I have given one table. In that table, you have to enter your student's detail. You have to enter your student name, USN, and contribution. Guys, suppose you people have mentioned 50% contribution, 25% contributions means, then definitely you are going to get marks for your contributions. See, for example, 10 marks I'm assigning you means you have mentioned 25% contribution means you are going to get only 2.5 marks. So I want 100% involvement in your project. So in contribution column, you have to mention 100%. So once you have mentioned 50%, once you have mentioned 25%, or you have mentioned 30% means you are going to get marks based on your contribution. So it is not like one problem we have given means, so one student is solving only HBase kind of thing, one student is solving MapReduce. So all 5 has to what? Contribute for the entire problem. So that's why in contribution you have to mention 100%. So carefully you have to fill that table. Okay, so that you will get to know. I will be what explaining again. So later on, after releasing assignment, I'm going to explain you again. No need to worry about that. So is this clear to everyone? So if you have any doubt, please do ask me, guys. So how about today's session? Shall I get one line feedback on today's session? After mid-sem, I'm seeing very less number of students. Okay. So 22 was the attendees at the beginning. Now the number is 14. Yes, can you all give me one line feedback on today's session? Or else you have any questions on assignment means you can ask me, guys. No questions? Okay, thank you, Niklesh. Kirtivasan, have you tried? I think you have started working with your lab, right? So any problem you have faced? Yes, sir. Now I am able to proceed. Okay, great. So that instruction I've given you in the slides, right? Sorry, not in slides, in recording. See, first 10 minutes I've taken for what? How to join HDFS. Is it? Yeah. So you're all able to access Labware? Yes or no? Labware problems are your assistants. Before you are going to solve your assignment, you go with the Labware. So we have given all the instructions line by line. Okay. So you have to execute all the commands to understand all these tools. Okay. Yes, guys, no questions means then we can wind up today's session. So I expected you people to give one line feedback, but I'm not getting any feedback. It's okay, not an issue. So no questions means we can stop this session. So is it okay for you all? Is it okay for you all, guys? Thank you all, guys. Thank you for your patient listening. So have a nice day. Yeah, Meghana, it will be completely theory concept. Thank you all, guys.